A celestial object from interstellar space was observed visiting our solar system for the first time. There are many mysteries, but none have captured as much interest as this enigmatic visitor known as Oumuamua. When it was first observed in 2017, Oumuamua astonished scientists and sparked great curiosity. Its strange cigar-like shape and unexpected acceleration raised many questions. But now, visionary Elon Musk boldly announces the return of Oumuamua. So, what exactly is this cigar-shaped object? Is it an asteroid, a spaceship, or something even more unknown? Join us on this adventure into the unknown and uncover the unexpected return of Oumuamua under the guidance of visionary Elon Musk. In October 2017, the University of Hawaii's Pan-STARRS telescope made a remarkable discovery in our solar system. This telescope, located near the Haleakala volcano in Maui, detected an interstellar object named Oumuamua. This telescope is renowned for detecting space rocks, even those as faint as Oumuamua. Officially named 1E/2017 U1, the Pan-STARRS team named this object Oumuamua, which means scout or messenger from afar in Hawaiian. Initially, Oumuamua was described as a reddish, elongated rock about a quarter-mile long and 10 times longer than it is wide. This extraordinary shape surpasses all asteroids or comets seen in our solar system. Its uniqueness can provide significant insights into other solar systems. One of the features identifying its extraterrestrial origin is its incredible speed, which exceeds the gravitational pull of the Sun. This distinct speed sets it apart from Kuiper Belt objects. Elon Musk has noted that this rapid movement is a clear indicator of an object originating from beyond our solar system. Oumuamua is a fascinating interstellar traveler. Oumuamua passed by Earth at an astonishing speed of 196,000 miles per hour, which is 109 times faster than a bullet. Scientists thought its origin was not from our solar system and initially couldn't decide if it was an asteroid or a comet. On September the 9th, 2017, the object was classified as an asteroid. Later, slight acceleration suggested comet-like behavior, but Oumuamua's unexpected speed surprised scientists, who closely monitored this cosmic visitor with telescopes worldwide. They examined its peculiarities closely. There was no visible dust or cometary tail. It had an elongated shape, 10 times longer than its width, and a reddish hue similar to objects in our outer solar system. As Oumuamua left our solar system, it had been wandering the Milky Way for hundreds of millions of years. It unexpectedly accelerated, defying the charts. This acceleration resembled the thrust caused by the sublimation of ice in a comet. But Oumuamua's speed and trajectory did not match predictions about its unique path in space since its 2017 discovery. Scientists studied Oumuamua's composition and origin, determining it reached a speed of 196,000 miles per hour. The leading theory suggests it could be solid hydrogen that vaporizes near stars. Some propose it is disc-shaped like a natural ion engine due to its acceleration pattern, while others compare its behavior to comets in our solar system. Meanwhile, radiation pressure from sunlight could explain the acceleration, but only if Oumuamua is extraordinarily lightweight. Its unique shape and low density have sparked lively debates. Some scientists even speculated that it could be an alien light sail constructed by an extraterrestrial civilization, though this view was met with skepticism. Oumuamua's distinctive feature is its ambiguous shape. While often depicted as a cigar, it might be more disc-like. We observed it from limited angles. Questions about its journey in nature, which turned the correct proportions of the solar system into a mystery, continued to intrigue scientists. In October 2018, Dr. Shmuel Bialy and Professor Avi Loeb proposed a theory suggesting that the pressure from solar radiation could explain Oumuamua's strange acceleration. Their research, accepted for publication in the astrophysical journal Letters, suggested that Oumuamua's pancake-like shape and high reflectivity resembled a light sail. This sail-like structure could interact with radiation pressure, causing the interstellar traveler to accelerate and deviate in its orbit. This idea generated both excitement and skepticism. Some sensationalized this theory as a possibility of alien origin, while others questioned its scientific basis. Professor Loeb defended his argument and wrote a book that delved deeply into his controversial theory. This book aimed to encourage both the scientific community and the general public to consider the possibility of Oumuamua being an extraterrestrial messenger. By presenting this controversial theory, it led to a deeper exploration of his arguments and further discussion about the mysterious origins of Oumuamua. Nonetheless, as Oumuamua prepared to leave our solar system in 2018, the final images captured by the Hubble Space Telescope showed its unexpected increase in speed, baffling scientists. Initially, they thought this acceleration could be due to outgassing, where material escapes from the surface of a comet because of solar energy. However, Oumuamua had no visible tail, and its sudden acceleration perplexed experts. If outgassing had occurred, gravity would have slowed it down further and caused Oumuamua to spin violently, which was not observed. Researchers like Bialy and Loeb suggested radiation pressure as a possible cause for the increase in speed. This raised the question of what Oumuamua could be if it wasn't a comet or an asteroid. Oumuamua's behavior baffled scientists because it defied natural explanations. Its brightness, shape, and acceleration, particularly the lack of a gas-emitting tail, did not align with existing theories. Professor Loeb is believed to be involved in the Starshot project, which aims to send a small spacecraft to Alpha Centauri. This project, propelled by a light sail and powerful laser, influenced the formation of his hypothesis. Loeb reached the idea that Oumuamua could be an interstellar probe, making careful calculations to determine the probe's size, composition thickness, and reflectivity. They analyzed all available evidence and ultimately suggested that Oumuamua was not a natural object. Although the light sail theory seemed unusual, it was supported by a logical and evidence-based approach. Loeb and Bialy adhered to a scientific principle similar to Sherlock Holmes' detective work. Eliminate the impossible, and whatever remains, however improbable, must be examined. They hypothesized that Oumuamua was an artificial object. Loeb presents this case by examining the limited evidence available. While we cannot definitively confirm that Oumuamua is an interstellar probe, it is beneficial to remain open to this idea. Elon Musk, who knows Loeb well, sees him as a brilliant thinker. Loeb's interest in the search for extraterrestrial intelligence led him to propose that Oumuamua could be an alien spacecraft. Although this idea has not been widely accepted among his peers, it intrigued him. Musk is also hopeful about alien life and is excited about this possibility, but he advises caution in assuming aliens as the direct explanation for unexplained events. Loeb noted that due to the limited information at the time, some research paths might have been missed. Loeb's theory is considered thought-provoking. It is important to consider it, along with other possibilities, and continue exploring the mysteries of space. In an interview, Elon Musk discussed the mystery surrounding Oumuamua's trajectory near the Sun, stating that if an object does not conform to the rules of gravity, another force must be at play, such as the melting of ice. In this case, aliens could also be a possibility. Musk does not entirely dismiss this idea, but prefers not to immediately propose extraterrestrial origins as the primary explanation. The question of what caused Oumuamua's unusual path remains ongoing. In early 2020, researchers proposed a fascinating theory about Oumuamua, suggesting it might be a hydrogen iceberg. They argued that pure hydrogen gas could provide thrust like a rocket. While this theory is intriguing, it encountered difficulties upon closer examination. A paper by Harvard and the Korea Astronomy and Space Science Institute raised doubts about its feasibility. Professor Avi Loeb and others voiced their skepticism for various reasons. The processes that lead to solid objects, like Oumuamua, could not apply to a hydrogen iceberg. The typical method involves small dust particles sticking together through collisions. But for a hydrogen iceberg the size of Oumuamua, particles would need to collide and stick repeatedly. These collisions, occurring at increasingly higher speeds, would generate extreme heat, instantly turning solid hydrogen into gas, preventing further growth and the formation of kilometer-sized hydrogen icebergs like Oumuamua. Moreover, an object like Oumuamua could not continue its long journey with a hydrogen iceberg composition. Such icebergs would quickly evaporate during journeys lasting hundreds of millions of years. If the hydrogen iceberg theory were correct, it could explain Oumuamua's cigar-like shape and non-gravitational acceleration. However, in September 2020, scientists had even more theories to keep the mystery of Oumuamua alive. An interesting theory has been proposed about the long space rock known as Oumuamua. Imagine it as a gigantic dust bunny, a large version of the dust and debris piles that accumulate under furniture. Elon Musk mentioned that scientists are considering Oumuamua as a giant form of this common household phenomenon. According to this theory, this strange space rock likely originated from a comet beyond our solar system. Oumuamua was formed from dust slowly flying off around the comet. This rock, accumulating on the core and solar radiation, was pushed into space, eventually making a brief tour of our solar system. Oumuamua's original comet parent likely had a long orbital period. These comets take a long time to complete their orbits around stars. Oumuamua, drifting away from them due to weak gravitational pull and radiation pressure, finally separated from its main comet and entered interstellar space. However, while this theory initially seemed convincing, scientists later found other ideas intriguing after 4 years of extensive research and the exploration of various theories. The astronomy community presented a new explanation in March 2021, suggesting that Oumuamua could be a large piece of nitrogen ice. This ice likely broke off from a Pluto-like exoplanet in a distant solar system millions of years ago. A natural explanation for Oumuamua's behavior was different from earlier speculations that viewed it as a rock fragment from a planet shattered by a star. These findings represented a significant shift from the extraterrestrial speculations that emerged when Oumuamua was first detected. Although initially met with skepticism, the nitrogen iceberg theory gained support. Astronomers like Scott Shepard, who were not involved in the study, found it plausible that Oumuamua could be part of an icy dwarf planet. However, the matter is not yet fully resolved. In their research, scientists examined the behaviors of different types of ice made of hydrogen, nitrogen, and oxygen. They discovered that under similar conditions, nitrogen ice could exhibit the same properties as Oumuamua. The challenge lay in measuring nitrogen gas. At the time, telescopes were occupied with such studies. They detected that Oumuamua had formed a comet-like tail. However, due to its nitrogen composition, this feature went undetected. Additionally, they identified potential sources of nitrogen icebergs, such as dwarf planets and objects at the outer edges of our solar system, like Pluto and Neptune's moon Triton. These bodies are known to have nitrogen ice on their surfaces. Based on the author's findings, Elon Musk noted that during the early stages of a distant solar system's formation, collisions between planetary bodies occurred, leading to the separation of a piece of nitrogen. This theory sheds light on the mysterious origin and behavior of Oumuamua's nitrogen iceberg. As it ventured closer to the Sun over time, it dared to enter the Milky Way and eventually wore down, giving it a flat pancake-like appearance. This scientific idea seems consistent with current observations and has been found plausible by other astronomers who praised the explanations. However, there were still some gaps. Professor Avi Loeb and Amir Siraj presented a different argument, suggesting that Oumuamua indicated the presence of many similar objects in our galaxy. However, if we assume that objects like Oumuamua are entirely made of nitrogen from exoplanets, there would need to be a significant number of them. Estimates made to determine the number of exoplanets in our galaxy led to two possibilities. Either Oumuamua was not entirely made of nitrogen, or we were significantly underestimating the number of exoplanets. Researchers checked whether there was enough material in the Milky Way to form all these nitrogen icebergs. As a result, they concluded that a substantial amount of additional material would be needed for such stars to exist. First, we need to understand how this material accumulates like a cosmic savings account. There are not many sources available for structures like icebergs around stars. Musk noted that for our galaxy to form so many nitrogen icebergs, it would need to convert 10 times the mass of all the stars into something called exoplutos. However, star systems do not have enough nitrogen ice to create that many exoplutos. Musk believes that cosmic rays erode interstellar objects like Oumuamua over time. If we factor this in, he states that our galaxy would need thousands of times its current mass. Therefore, nitrogen ice might be insufficient to explain Oumuamua's origin. However, not everyone agrees on how often objects like Oumuamua wander the galaxy. Some scientists argue that such objects are rarer than we think. Professor Loeb suggests a high density, indicating that there are multiple interstellar objects in the galaxy. Others believe these objects are rarer, with an estimate of one object per 333 astronomical units. The choice of density significantly alters the calculations. For those adopting the second view, the nitrogen ice theory could still hold. In March 2023, however, scientists refocused on hydrogen as a possible explanation for Oumuamua's properties and origin. A study by two astronomers used principles of chemistry to try to solve the mystery of Oumuamua. Their study suggests that despite its unusual composition, Oumuamua is actually a comet. Their theory proposes that Oumuamua accumulated hydrogen gas over millions of years due to cosmic radiation, which got trapped within the comet's icy structure. During its journey through interstellar space, radiation from cosmic events like supernovae may have converted some of the comet's water ice into hydrogen. This hydrogen gas might have created a sudden acceleration as it was released when Oumuamua approached the Sun. Astronomers consider this model one of the most plausible explanations proposed for Oumuamua so far. This theory, as Musk pointed out, explains Oumuamua's strange behavior upon its departure. Additionally, there are studies from 40 years ago showing how cosmic rays can extract hydrogen from water ice and how this gas can get trapped within icy structures. Some astronomers find this explanation satisfying and understandable. This theory helps resolve the mystery of Oumuamua's behavior and composition, making it less mysterious than previously thought. However, some scientists question this explanation. Professor Avi Loeb argues that errors were made in calculating Oumuamua's surface temperature, leading to incorrect estimates of hydrogen in the iceberg. This means the release of existing hydrogen could not account for the observed acceleration in Oumuamua. Currently, Oumuamua is too far away for further measurements, and it is unlikely to return for further examination. However, astronomers are hopeful that future sky surveys will uncover more interstellar objects like it. The Pan-STARRS 1 telescope, which first detected Oumuamua in 2017, captures high-quality images of the entire sky every 2 to 3 days. This technology allowed for the detection of extremely faint objects, considering Oumuamua's rapid movement. Covering the sky was crucial as the observation window for Oumuamua in our solar system lasted only a few weeks. Musk noted that astronomers have confirmed only 2 interstellar objects so far: Oumuamua in 2017 and Borisov in 2018. However, many more are believed to exist. Unfortunately, scientists had limited opportunities to study these objects after discovering them. NASA sees great potential in the James Webb Telescope for studying such interstellar objects. Musk believes this powerful telescope will provide unprecedented information on their chemical compositions, origin formation processes, and the conditions in their home systems. This promises to expand our understanding of the vast cosmos and provide valuable insights into these celestial travelers. Interstellar objects like Oumuamua are akin to hidden treasures. The James Webb Telescope and other space observatories promise to unveil the secrets of cosmic knowledge. Studying these cosmic travelers is vital, as Oumuamua offered only a brief glimpse while passing through our solar system. Detecting and examining more objects like Oumuamua can validate or refute various scientific theories about them. To learn more about their origins, some scientists are planning to study these objects as they pass through our solar system. The general consensus is that collecting a sample from these objects would be a remarkable achievement. The European mission called Comet Interceptor, deployed around the Moon's orbit to launch a rocket into space and be prepared for the next Oumuamua-like visitor, marked a significant milestone as humanity's first direct exploration. After decades of theoretical speculation, evidence of interstellar objects has been obtained. However, as of March 2023, Oumuamua has passed far beyond Neptune's orbit, heading towards the constellation Pegasus, and it will not return. It is now too distant for our telescopes to provide meaningful observations. It likely came from the general direction of the bright star Vega about 300,000 years ago, but Vega was not in its current position at that time. Even though Oumuamua was traveling at speeds up to 59,000 miles per hour when it entered our solar system, it could not have traversed such a vast distance in a short time. Therefore, the true origin of Oumuamua remains a mystery.